Welcome to Hyperledger Besu. In this course, we'll turn Ethereum-compatible blockchain from a buzzword into an architectural tool you can evaluate, build with, secure, govern, and deploy with confidence across public, private, and permission networks. We'll move step by step. Besu fundamentals first, then architecture and design, development, governance and security, and finally deployment. By the end, you'll be able to connect the concepts to a production-ready blockchain solution. The sequence mirrors how a real enterprise blockchain effort should mature. We start with platform fundamentals, so technical choices stay tied to business value. Next comes network design, because weak architecture is difficult to repair later. Then we build applications on top of the network. Before going live, we address governance, compliance, and security. Finally, we bring everything together in an end-to-end deployment scenario. Use this course in the way that fits your starting point. If you're new, go sequentially and let the fundamentals build your mental model. If you already develop or design systems, focus on architecture patterns, implementation choices, and trade-offs. If your role is operations or leadership, use the later sections as a reference for deployment, governance, and production readiness. Whatever your level, stay active. Take notes, sketch designs, pause, compare options, and test ideas locally. Let's begin with the core question. What is Hyperledger Besu? At a high level, it is an Ethereum execution client designed to connect public Ethereum compatibility with enterprise-grade blockchain networks and Hyperledger's open-source ecosystem. Hyperledger Besu is an open-source Ethereum execution client written in Java. In practical terms, it is software for running an Ethereum-compatible node. That node can connect to public Ethereum networks, or it can power private and permission networks inside an enterprise. Besu matters because it brings Ethereum standards into environments where control, security, and integration are important. Think of Besu as the engine for Ethereum's execution layer. Applications send requests through JSON-RPC APIs, and Besu checks each transaction against protocol rules. When a transaction is valid, Besu executes the smart contract logic in the EVM, calculates the result, and updates account balances, contract storage, receipts, logs, and world state. Those updates are included in blocks and shared with the network and supporting tools. Besu's flexibility comes from supporting different network models with the same client. On a public network, participation is open, so compatibility and decentralization are central. In a private network, access is controlled, which is useful for internal development, testing, or consortium pilots. In a permission network, approved nodes or accounts participate under defined governance rules. Each model changes assumptions about trust, access, performance, and compliance. Besu fits into Ethereum because it speaks the same core language. It understands Ethereum-style accounts, transactions, blocks, and state. It runs EVM-compatible smart contracts, so Solidity contracts and familiar development patterns carry over. It also exposes the JSON-RPC interfaces that Ethereum tools expect. As a result, wallets, Web3.js, Ethers.js, and common developer workflows can connect without teams reinventing their stack. That compatibility becomes visible in day-to-day development. An application can call familiar Ethereum JSON-RPC methods, such as eth_a_block_number to read chain state, eth_a_get_balance to inspect an account, or eth_send_raw transaction to submit a signed transaction. Behind those calls, smart contracts run in the EVM, keeping execution deterministic and Ethereum-like. This is why many existing tools, libraries, and development habits transfer directly into Besu networks. On public Ethereum, Besu can run as the execution client for mainnet or testnets. Its role is to process transactions, run smart contracts, and maintain execution state. Since the merge, Besu does not handle proof-of-stake consensus by itself. It pairs with a consensus client, which manages validator duties and block agreement. Together, they form a complete Ethereum node, while applications interact with Besu through JSON-RPC. Besu's place in Hyperledger is important because it connects Ethereum capability with enterprise open-source governance. From Ethereum, it brings familiar tooling, smart contracts, and EVM compatibility. From Hyperledger, it gains a collaborative ecosystem focused on real business networks. That makes Besu useful when organizations want Ethereum features, but also need permissioning, compliance, identity, and operational control. A common mistake is treating Hyperledger as a single blockchain choice. Besu, Fabric, and Indy solve different problems. Besu is the Ethereum-compatible option, especially when EVM smart contracts and Ethereum tooling matter across public, private, or permissioned networks. Fabric is built for controlled enterprise consortia with modular workflows. Indy focuses on decentralized identity. The right choice depends on your contract model, identity needs, governance rules, and ecosystem fit. The practical value of Besu is that teams can use familiar Ethereum tooling while designing networks for known participants and enterprise controls. That makes it useful for tokenization, supply chain asset tracking, settlement and audit workflows, and consortium data sharing. It also gives teams a way to test governance, privacy, and architecture choices before committing to a production blockchain. You now have the foundation for Besu, a Java-based Ethereum execution client that works with public Ethereum and private, permissioned enterprise networks. You can place it within both Ethereum compatibility and the Hyperledger ecosystem. Next, we'll compare public, private, and permissioned blockchain models.